The long shaft is considered to be made of sheet metal. At first glance, it was guessed to be extruded because of the smooth, seamless finish. However, inspection of the inner profile revealed the seam, therefore leading to the conclusion it was rolled sheet metal, with the mounting holes punched prior to rolling. Alternatively, the shaft could have been produced through extrusion starting from stock billet. Extrusion can be favorable for production rates as it is a one-step process as opposed to having sheet metal stamped and then rolled. However, the workpiece is more suspect to post-process expansion and the holes would have to be drilled afterwards, which is more difficult than punching as the surface is curved. The crevice tool attachment had a noticeable seam running lengthwise of the inner and outer profiles. The manufacturing process behind this could have started as two injected molded halves that were then joined together by ultrasonic welding. The lower rolling assembly is made of acrylonitrile butadiene styrene. Each piece is made through the process of injection molding joined together with screws. The tubular attachment piece was injection molded in two halves, then ultrasonic welded together. The handle assembly consists of two halves joined together by screws to also hold the shaft. As the stamping reveals, it is composed of ABS plastic. The circular ejection pin marks suggest these halves were injection molded. The main housing consists of two ABS plastic injection molded halves joined together by screws. It is believed that the housing is injection molded because of the intricacies and cutouts featured, and it is also evidenced by the ejection pin marks seen on the inside of the two halves. The switch assembly is held together in thin, stamped sheet metal. Having a very simple on-off function, the wire soldering is likely done by hand. In total, there were only 4 soldering points. The vacuum's motor casing consists of two stamped sheet metal ends. Both ends clamp onto the laminated stack consisting of a multitude of thin stamped plates made of metal. Alternatively, the laminated stack could have been diffusion bonded, but that would take far longer and be much more expensive. The wire for the coils is likely made of copper for its high conductivity properties. The coils may have been hand-wound, as they bear little resemblance to the more orderly machine-wound examples. The fan was most likely made of two injection-molded pieces, which were then ultrasonic welded together. A metal collar was embedded into the half closest to the motor, which was then press-fit onto the motor shaft. The metal spring was most likely made by taking wire and winding it around a special shaft called an arbor. This process can be done at room temperature and can be completed very quickly, resulting in a high production rate. An alternative process to making a metal spring is by using a CNC machine, but it is a time-consuming and expensive process.